All right, everyone. So we have two major concepts left in 8th grade math to get ready for Math 1. And again, these are things that come back in Math 1 over and over and over again, and you've got to know them before you're going in. And one of them is the Pythagorean theorem. The other one is going to be exponent rules, and we'll get to that as we get into May. So Pythagorean theorem is going to be the focus of the second half of this week and the first half of next week. And basically, the Pythagorean theorem is a rule, it's a formula, an equation, whatever you want to call it. But what it does is it allows us to find side lengths of only right triangles. So that is important. It allows us to find side lengths. I just wrote the word. It allows us to find side lengths of right triangles. So one of the things that is important to notice is that in order to be able to use the Pythagorean theorem, you have to know that you are looking at a right triangle. So again, here I'm looking at a right triangle. I know this because this box, the square in the corner of where your vertical and horizontal meet, always indicates that we have a right angle. So a right triangle is made up of three pieces. It's made up of two legs and then a piece that's called the hypotenuse. So the Pythagorean theorem allows you to find any one of these side lengths as long as you know two of them. So if you know A and C, you can find B. If you know A and B, you can find C, so on and so forth. But what the Pythagorean theorem says is that A squared plus b squared, so hopefully you see why we were talking about squares and cubes, a squared plus b squared is equal to c squared. So in order to do this, you're going to want to have a calculator, you're going to want to have a Google calculator, whatever works. I'm going to be using the calculator on my phone. So you don't need something fancy to do this. But what I'm going to do right now is go ahead and show you why this formula works, and then we're going to look at several examples together. So when we go down here, it will go into A, B, and C and like the pieces assumed, so don't fret about that. But the reason that this works is that if we really think about what the Pythagorean theorem tells us, which is that A squared plus B squared is equal to C squared. Well, we know that if we take something and we square that length, we're actually forming a geometric square. So what's happening here is you've got A squared. So in this case, this is going to be a 3 by 3. So that gives you 9. So in this case, this is going to be 3 squared. So this 3 by 3 square comes in and actually I want to start with this in the image. So we've got a 3 by 3 square here. And then down here we have a side length of 4. So this is a 4 by 4 square. So that's going to be 4 squared. Now, one thing that is important for you to know is that on a coordinate grid, you cannot count a diagonal side length. This one right here is something that is referred to as a perfect example. A 3, 4, what's going to come to be 5 right triangle, but you cannot count a diagonal side length on a graph, and we'll come back to that later. But in this case, I know that 3 squared plus 4 squared is going to be equal to, and I'm going to assume I can't count that line because it's diagonal, so I'm going to say c squared. Well, and I guess if I want to show you, I have to let you know that that's 5. Okay, so we're actually going to let you know that this is 5. Again, please recognize you cannot count the side length of a diagonal. So this would end up being 5 squared. All right, so we've got 3 squared plus 4 squared is equal to 5 squared. Well, right here, I have my 4. So I've got 3 squared, that's 9. So this area here is 9. I'm adding it to 4 squared. This area here is going to be 16, and it's telling me that it's going to equal 5 squared, which is 25. So it's basically telling me that if I take this side length, the area of the square that it creates, added to the area of the square that this side length creates, is going to be the area of the square created by the hypotenuse. So right here, I'm going to take this 4 by 4, so 1, 2, 3, 4, and this right here is my 4 by 4 right there. Now I also here have 9, so these 3 and these 3. And then I have 3 right there, so that's the 9 of my second square. So again, I know that the 9 plus the 16 here is 25, so that is why my rule works. So now that you've seen that, we're going to go look at how the Pythagorean theorem works. So again, some important things to note is that C is going to be the most important thing to identify because the formula says that A squared plus B squared is equal to C squared. So it's basically leg squared plus leg squared is equal to hypotenuse squared. And it does not really matter which one is A or B. So if you plugged one in for A and one in for B, it wouldn't matter, but it does matter which one is C because C is over here by itself. So when you are solving an equation, you can't just interchange the values like you can with A and B that are over here together. So some things to note about C. C is called the hypotenuse. We're not going to write that because I don't remember if I left space for that. So the most important thing to know about C, the hypotenuse, is it is the longest side of the triangle. So again, the hypotenuse will always be the longest of the 3 sides. The hypotenuse is always across from the right angle. So if you are looking at a triangle and you want to know where C is, well, you start with the right angle. Across from the right angle, you'll find C. Here's my right angle. They flipped the triangle, but across from it, I'll find C. Again, here's my right angle. Across from it, I will find C. So again, you're always going to be able to find it across from the right angle, and it's always going to be the longest side. And yes, the third fact is that it is called the hypotenuse. Important things to remember is only one kind of triangle has a hypotenuse, and the kind of triangle that has a hypotenuse is a right triangle because the Pythagorean theorem only works with right triangles. All right, so now we're going to see how this works, and it will not take very long, and then we'll be done. So it is asking us to find the missing side length of the following triangle. All right, well, I'm looking at a right triangle. I know that because of this, and I also know that I'm given 2 of the sides, so I can use the Pythagorean theorem to find the third. So I'm going to say A squared plus B squared is equal to C squared. Now, anytime I start a problem, I have to figure out, am I finding a leg or am I finding the hypotenuse? Well, here's my right angle. Across from it is this side length. This is the side length I don't know, so it is C because it's across from the right angle. Because the one across from the right angle is C, that means these are A and B. It does not matter which is which, as long as you know which one is C. So I'm going to make 7A, I'm going to make 10B. So when I go to set up my formula, I say that 7 squared plus 10 squared is equal to C squared. I don't know C, so I leave it as C squared. It's like a variable here. Well, 7 squared is 49, and 10 squared is 100, so that's going to be equal to C squared. Well, now I'm just solving my equation. I'm trying to figure out what C is. It's already by itself, so I keep solving. 49 plus 100, that says 149 is equal to C squared. Now, this is where if you did your work last week, you should know what to do. I don't want C squared, I want to get C by itself, so I take the square root. That leaves me with C. I go to the other side here, and I take the square root of 149. So 149 is not a perfect square, so my answer is the square root of 149. Now, I also want you to give me a decimal equivalent. So again, the answer is the square root of 149. Think about it. It doesn't make sense for this to be 149 units long if this one is 7 and this one's 10. So don't make the mistake of forgetting to take the square root at the end. So I'm going to take the square root of 149 and I get 12.20655, blah, blah, blah. I'm just going to round to the nearest tenth, so I'm going to cover up everything except for the 12.20. Well, the 0 is not going to change that value, so this is 12.2. So you can say either that C is the square root of 149 or that C is 12.2. Those mean exactly the same thing. All right, so let's look at the next one here. And what you're going to do here is you're going to figure out whether you're looking for a leg or the hypotenuse. So a squared plus b squared equals c squared. I'm going to know across from my right angle, I have this side length and I don't know it. Well, it's across from my right angle, so it is c. So again, in this problem, I'm looking for c. So this is going to be A, this is going to be B. Again, doesn't matter. You could have made this B, this A, same thing. So A squared is going to be 6 squared plus 3 squared, B squared, is going to be equal to, I don't know C yet, so it's equal to C squared. So I'm going to solve my equation. 6 squared is 36 plus 3 squared is 9, and that's equal to C squared. Well, now I just have to do 36 plus 9, and that gives me that 45 is equal to c squared. But again, I don't want the value of c squared, I just want normal c. So to make the squared go away, I take the square root, and I get that c is equal to the square root of 45. And again, I want to go get my decimal answer, so I take the square root of 45, and I cross that again, I cover up everything except for the 6.70, so this becomes 6.7 is equal to C. If you're using your phone calculator, the square root key looks like that. So a square root has a 2 on it technically, but it's kind of like a 1 on an X, you don't write it. So that's that key if you're using your phone calculator. All right, so on this one, I've got 3 and 10, and I'm trying to find this side length. Well, it is the side length that is across from the right angle, so it is C. So what's going to happen now is you are going to get that a squared plus b squared is equal to c squared. That's 3 squared plus 10 squared is equal to c squared. It's going to give me 9 plus 100 is equal to c squared. 109 is equal to c squared. All right, so now I'm going to take the square root, and I get that c is equal to the square root of 109. And now I am going to take square root of 109, and I get, if I cross out everything except for the 14.44, or excuse me, the 10.44, I get 10.44. Well, this does not make that 4 get larger, so I'm just going to say 10.4 is the value of C. I know that C has to be the longest side length. Well, 10.4 is bigger than 4, so that makes sense. So in just a second, what you're going to do is I'm going to scroll down. You're going to see 3 new questions. Pause the video, solve those out by yourself. When you press go again on the video, the answers will be there. You're just going to check your answers, make sure you know what you're doing. Please do not think that you are the master of this yet, though, because remember, in these 3 examples, all we did was find C. So after those, I'm going to do 3 more examples where we're looking for A or B instead of C. It's a little bit different, so please, please, please don't stop watching. It has only been, I know it's been a little bit, you're going to be okay. This is all you have to do today. There's no quiz for today, no nothing. All it is watching this video, so you can do it. All right, so again, pause the video, and I'm going to go down here, so actually don't pause the video yet. Now that you can see these questions, go ahead and pause the video. I'm going to pause recording so you won't have to watch me work through them all. When you press play, the answers are going to be on here and you can just check your work. All right, so those are the solutions with the work. Go ahead and pause it to take a second to check your work, look over anything you need to, and I'm going to keep moving forward. So the next kinds of questions are very, very similar. So the only difference here is that when you go to figure out what you're missing here, you go and you draw your arrow over, so from your right angle, and you recognize that you already have the value of C. So this one, let's make it A, and this one we don't know yet, X, so let's just decide that our B value right now is X. So this question again is going to be a little bit different when we go to solve it because we are no longer looking for the value of the hypotenuse. We are actually going to be looking for the value of B here. All right, so we know that A squared, so we've got 15 is A, so that's going to be 15 squared plus, we don't know B, so let's put X squared, or you can put just B squared, whichever you prefer. You can use X as the variable, B as the variable. But we know what C is. C is 25, so that's going to be equal to 25 squared. So some of you are seeing that this is actually just going to turn into an equation like you learned last week. So 15 squared is 225. So this is 225 plus x squared is equal to 25 squared, which is 625. So what I need to do now is I need to get x by itself. So I need to subtract 225 from this side, and I need to subtract 225 from this side. So that side's going to go away, and I'll be left with x squared is equal to, well, 625 minus 225 is going to give you 400. So we know that x squared is equal to 400. Well, this can't be 400 because the longest side is 25. We already know that. Well, this is x squared. So remember, when you have x squared, you need to take the square root. So to get x, we take the square root of 400. And when we take the square root of 400, we get a nice even number. We get that x is equal to 20. So here we get that x is 20 feet. Well, it needs to be shorter than the hypotenuse. It is, so it makes sense given the answer. So again, when you are trying to find the leg, it's very, very similar. You're just working backwards a little bit. So next thing that we're looking at here is going to be similar. We're going to go across from our right angle, and we know that we already have that value. So 15 is C. So let's, for this for fun, same thing. Let's just make this one A, and let's make this one B. So we're going to do A squared plus B squared is equal to C squared. Well, A is, we don't know it, so that's A squared. B is, well, we know it's 12, so that's going to be plus 12 squared. And that's going to be equal to, well, across from the hypotenuse is your value of C, so that's going to be 15 squared. So at this point, I know I'm looking for A, so I'm going to continue solving my equation. This is going to give me A squared plus, well, 12 squared is 144 is equal to 15 squared is 225. Well, I want to get A by itself, so I'm going to subtract 144, and I get that A squared is equal to, so we do 225 minus 144, and we get 81. So again, 81 cannot be the value of the leg if the hypotenuse is 15. It also just doesn't really make sense, but A squared is 81. That cues that I need to take the square root. So I get that A is equal to, well, the square root of 81 is 9. So there I get my value of 9. So these have all had nice perfect squares there. They don't have to. You could have ended up just like in the first ones with like the square root of 50 where you can't solve it out and you get a decimal. That's absolutely fine. So don't freak out if that happens. All right, so in this next question here, we are going to take our right angle, we're going to go across from it here, and we know that our C value is 20. 16 is going to be one of our values. Let's make it A just for fun, and let's make that one B. Again, the legs are A and B. It doesn't matter which one is which, as long as the hypotenuse is C. So I've got A squared plus B squared is equal to C squared. Well, A is 16, so that's going to be 16 squared plus B squared, because we don't know it, is equal to C squared, so that's 20 squared. So when I go to solve these here, I get that, well, 16 squared is 256. So I get 256 plus b squared is equal to, well, 20 squared. We looked over here, the square root of 400 was 20, so 20 squared is going to be 400. Now I subtract 256 from each side. So 400 minus 256 is going to give me another perfect square. I get that b squared is 144. Take the square root, and I get that b is equal to 12. Again, you do not have to get a perfect square here. You could get anything. You could have to get a rounded answer. So don't think you're wrong when you go to do these next ones if you get decimals. So again, we're going to do just like what we did on the first one. You've got these questions right here. And again, go ahead and pause your video and you can work these out. I'm going to pause recording, work them out, and then when the solutions are here, I'll hit play. All right, everybody, so these are your solutions here. So you're going to get your x equals 8, and then again, here's what I warned you was going to happen. You got x equals square root of 540, which was 23.2 when you rounded, and then the square root of 377, 19.4 when you rounded. All right, so these are our final examples for today, and again, these are just 2 Pythagorean theorem questions. So it is telling us the hypotenuse of a right triangle is 33 centimeters long and one of its legs is 28. It says, what is A, the length of the other leg? So let's draw this triangle here, and it says the hypotenuse of it is 33 centimeters long. So that's right there. And it tells us that one of the legs is 28. Now remember, it doesn't matter which leg, because it doesn't matter which one's A, which one's B. So one of the legs is 28. Let's make it that one. And it wants to know what's the length of the other leg. So let's fill it in. We know the legs are either A or B. So I guess in this case, we're making this one A and this one B. This one, it tells us, was the hypotenuse. So that's how we knew to make it C. That's how we knew to put it across from the right angle. So now I want to find the length of the other leg. That's A squared plus B squared is equal to C squared. So that's going to be A squared plus 28 squared is equal to 33 squared. So again, that's A squared plus, well, 28 squared, that's 28 times 28. That's 784 is equal to 33 squared. So that's 1,089. So we subtract 784 from each side. And we get that A squared would be equal to 305. We take our square root, and that gives us that A is equal to, when we take the square root of 305, we get 17.46. Well, that 6 is going to round that 4 up, so we're going to make that 17.5. So that would be the other leg of that triangle. All right, so we're going to do one final problem together, and then again, you're going to have these two, which are going to be just like the two we're doing, and then you are done for today, as long as you've done the Monday, Tuesday work. And here we go. So right here, we have a man. So these ones with directions, they're always going to be a Pythagorean theorem one if it tells you two directions and then asks from a starting point. So just say you start here. So it says you drive 6 miles west. So you can assume you've got north, south, east. Wow. I said it and then I wrote random letters. North, south, east, and west. So if he's driving west, you can just go to the left and say, well, that's 6 miles west. And then 8 miles north, well, that would put him up here, 8. So he wants to know how many miles the man is from the starting point. Well, the starting point is back here. So basically, it's saying if you go 6 miles this way and 8 miles this way, what is the distance if you just went straight back home? So it's going to be longer than 6 or 8, but it's going to be shorter than 6 and 8 added together. So 6 and 8 added together would give us 14. So we know that we're going to have a length that's smaller than 14 but bigger than 6 or 8. So to find this distance, we're going to use the Pythagorean theorem. So if we went west and then north, that puts our right angle right here. So if I go across from that, this value, the distance home, is going to be our C value. So 6, let's make A, 8B. Again, it doesn't matter which one is which. You do A squared plus B squared is equal to C squared. So A squared is going to be 6 squared plus B squared is going to be 8 squared is equal to C squared. So here that's 36 plus 64 is equal to C squared. Well, 36 plus 64 is 100. So we've got 100 is equal to C squared. Well, let's take the square root of each side there, and we get that C is equal to 10. So at this point, you've got a C value there of 10. The man is 10 miles from his starting point if he were able to travel straight along the hypotenuse back. So again, go ahead and do these 2 questions, and I'll pause the video. I'll show the solutions. But again, this is Wednesday. That was it. It's just watching this, knowing what's happening. The Thursday work is just a quizzes based on can you find the side length or the hypotenuse of a right triangle using the Pythagorean theorem. Then Friday we'll have a Zoom class, and then you'll have a little 5-question skill check, and that's it. So not too much. Thank you for participating. Hopefully this makes sense. And then you'll have some practice with it tomorrow. Friday we'll see what we're going to do with it. All right. Again, do these ones and then hit play again, and we'll be done. All right, so your final solutions here should have been the square root of 387 or 19.7 and the square root of 1233, which is 35.1. All right, thank you for learning this. Again, this will come back. We'll be doing it the rest of this week and next week, so we'll start using it now. All right, thank you guys. Hope you're well. Bye.